And with that, let's kick it off. So thanks again, everyone, for joining us today for the webinar on how to decarbonize your software company. Plan A, being a software company ourselves, would like to share our expertise in this area. And the two amazing speakers we have with us today do represent the team's expertise. And I have the pleasure of working with them at Plan A. So let me just start with introducing them and myself and walk you through the topics of today's presentation. So first, let me start with introducing the first speaker, who is Carsten Windler, Director of Platform at Plan A. Carsten is a passionate web developer with over 20 years of expertise in software development in various companies and industries. And he is a true advocate for green IT for several years now, at least since I know him. It's been pretty clear that he is an expert also in this domain, and also regularly speaks at developer conferences and shares this expertise with the public, also through several publications. The second speaker is César Vaca, who is the decarbonization lead at Plan A. César is an engineer by background and has gathered over 12 years of experience in delivering decarbonization strategies, all the way from target setting to showing decarbonization solutions also across multiple sectors. And one fun fact maybe about César, he likes to say that emissions are only a symptoms, and we should look at the business activities underlying a certain company to identify the root causes. And you will learn a lot more about this in today's presentation. And finally, I'm your host, Claudia Hlavackova, and I work as a decarbonization management associate at Plan A, focusing mostly on identifying decarbonization trends and opportunities for our clients in various industries, and also work on linking the policy developments and decarbonization space. Super excited to be here and host this webinar. Just to set the scene and give you an idea or outline what we're going to be covering today. As you might know, our colleagues from the carbon accounting team at Plan A held a webinar in February on decoding carbon accounting for software companies. If you hadn't attended that webinar, don't worry. We'll summarize it really briefly in the beginning. If you have, this is a great continuation of that webinar series. After that, we'll walk you through a typical decarbonization journey, what it consists of, and how to best design it. Afterward, we will offer some tangible decarbonization options and dive a bit deeper into cloud services and renewable energy considerations before moving on to the Q&A. So that also leads me to reiterate one more time, please do scan the QR code, which will be posted in the next slide, or join us at slido.com #PlanA. Maybe the team can, in the chat, can post #PlanA in the chat so you can join us at slido.com. And with that, I would like to thank you again for joining us, and hope we have a very engaging session, and hope you can learn. So let's kick it off with this quote, actually, which we have taken from an interesting study on sustainability practices for data centers, which puts to focus on three important trends the tech industry in general and the software and IT industry specifically is currently facing and will continue to be facing in the next year, which is the rising energy prices, rising energy consumption due to the digital growth, innovation, and artificial intelligence, and of course, the unstoppable move towards sustainability, which we probably the reason why we're here also. So the increasing trends towards sustainability and decarbonization of business operations. So we will cover these topics during the webinar, and hopefully you'll leave with having clear ideas on how to improve your company's sustainability strategy. Before I give word to my colleagues, I'd like to maybe recap what the carbon accounting webinar, so our colleagues from the team at Plan A have talked about last month, where they essentially dive deeper into the different emissions categories that are mostly material for software companies. Now, as you might know, maybe some of you are very familiar with this, maybe some of you are just starting the journey. The global standard on calculating emissions, the GHG protocol, classifies emissions into three categories or three scopes, scope 1, 2, and 3, where scope 1 and 2 or in simplifying terms, so to say, scope 1 comes from direct burning of gases on site, scope 2 comes from purchased electricity and heating, and then scope 3 is, as you can see on the left-hand side in the graph, usually the biggest chunk of emissions for software companies, and that comes from upstream and downstream value chain. And on the right-hand side, you can see a graph that we have compiled based on several hundred companies, actually, which dives a bit deeper into scope 3 emissions. And you can see here there is 15 categories. Usually the highest one for a software company is use of sold products. So the usage comes from the usage of the product by your clients. And then also scope 3 category 1, so purchase goods and services. What we're trying to, or my point here is that, as you can see, we also split these emissions into product related and operations related. So product related, by that we mean the actual emissions coming from your software. By operations, we mean things like your companies traveling for example, conferences or any other operational emissions that your company might have. And today's webinar is focused on the product related emissions, right? So we will be proposing tangible action to how to decarbonize the emissions stemming from your software product, rather than strategies on how to, for example, reduce business travel emissions, which we also have expertise in and a lot of resources. So feel free to head to our Plan A Academy to learn a bit more about how to reduce those emissions. And last note before I go to the next slide is that this is of course true for a typical software company. So this is an average, I would say. Your emissions profile might look vary or a bit differently based on the way you operate and the way your business model is structured. Moving on to the first interactive element. So please, again, scan the QR code or join us at slido.com, #PlanA. We would like to understand a bit more before going a bit deeper, where in the sustainability journey you are currently at. So have you just calculated your carbon footprint or you are just starting, or you already maybe identified some decarbonization opportunities, or maybe already implemented some, which seems to be increasingly the case. So it seems that we have around 15 people, 16 people counting, seems to be increasingly, or the majority seems to have already calculated their carbon footprint and implemented some decarbonization actions, which is extremely exciting. And I'm super happy to see that. I do believe that, or at least I hope that you can learn a lot today and see which other decarbonization actions you can implement, or ask any questions regarding the ones that you have implemented, or that we will give practical tips and tricks on, how to kind of advance your journey. Great. Thank you, everyone. This sets the scene quite well. And with that, I'd like to invite César to give us a bit more insight into how a decarbonization journey of a company can be structured. So a lot of our audience today has already implemented some decarbonization actions, but maybe if César, you could share this scene, so to say, on how this usually looks like and where to go from having already implemented some decarbonization actions.
Yes, of course. Thank you, Claudia, and good morning, everybody. Yeah, it is very interesting to see in the previous slide in the poll that a lot of you have already finished your CCF calculation, and additionally, you are exploring or even implementing your decarbonization actions. That's pretty cool. In fact, while some other people in the audience have answered that they are probably identifying. So the point here is that throughout this webinar, you will see that we will present some actions with different levels of deepness and detail, and potentially also the difficulties or the challenges, let's say, in the implementation of those will vary. And that's fine, because we also need to tailor or to adapt these suggestions of reduction actions to the current practices, but also to the state of the journey in the sustainability journey of the company, right, in which you are. So this slide is presenting a typical structure of how the sustainability journey looks like. So in the first step, as you see, we have the calculation of your carbon footprint that, of course, as you have already done, it is for setting the system to collect the data and to manage the data that enables you to calculate your emissions, but also then to analyze what it is your historical emissions with the current year in order to identify trends, what it is going up or going down. And of course, all of this entails also other elements, like, for example, having a good understanding of your scope 3 emissions that, as we saw before, can be very, very important, right, in comparison with the rest of the scopes. After that, you will move to the, broadly speaking, a second step, a second branch, that it is called the plan your decarbonization strategy, in which you, based on your emission hotspot, already identify what can be your decarbonization levels, what are the actions that are more effective and actionable, implementable for your case. And of course, this needs to lead to the accomplishment of some targets for the short and the long term that you have placed for yourself, right? And of course, these targets and the decarbonization activities need to make sense and to be connected, let's say, with your sustainability policies, with your sustainability strategy within your company, but also make a match with your business goals and business strategy. That's very important for general success. Then after that, you will start reducing your emissions by actually implementing the plan of the decarbonization. And for this, for example, you will require engaging with your internal, but potentially also with external stakeholders to implement the actions. You probably will need to educate and to implement processes for awareness and education and an overall understanding. And then you will monitor, it is necessary that you monitor and track the progress towards your targets. And finally, you will improve. And in improve, we mentioned things like, for example, expanding the scope of the action, probably already involving your value chain actors, like, for example, your suppliers, but potentially also the clients. And you will find that it is necessary for expanding the scope and being more ambitious to continue optimizing the data collection, going deeper into the data collection. So, for example, changing some averages that you have been using with actual data from your own operations, but also the value chain, and then to optimize, generally speaking, the process. And then you repeat, but not going to the beginning, because you will be more enforced, you will be more in a better situation. That's why we present this kind of an spiral, saying that you will be start over, but in a next level, in a more advanced way. So as I said, the actions that you will see here will be tailored following this logic.
Thank you, César, for setting the scene. I'm still curious though, because we also do have some participants that are just starting the journey in their climate strategy or climate journey or sustainability journey. So I'm just curious if this framework that you just described applies to everyone equally, or if there's different levels or different ways to look at it for someone just starting the journey.
Yeah, I think that this can apply in general terms to every company. It is, let's say, a template, so to say. But of course, this needs to be tailored, and as I said before, they need to make a match with the business strategy and with the sustainability strategy. So we tend to talk about companies that can be, for example, understood, or that they can see themselves as climate leaders. For example, those companies that have very ambitious targets, like, for example, going to net zero, that have been already implemented this cycle, and they are in a further step. So they are going for some very ambitious and highly detailed decarbonization actions. While other companies, for example, can be just looking for what it is in their industry, what is the best practices at industry level. So they want to benchmark with their peers in order to not to lag behind. So they are actually understanding what it is there to be at the front, but also not putting an unnecessary overburden on their shoulders. While other companies can be, as I said before, just starting the journey, so they probably need to start exploring what it is in their own operations, having a good understanding of their own CCF emissions, and potentially, for example, the first actions for the decarbonization can be in scope 1 and scope 2, meaning the things that they can actually influence directly, right? So once again, the idea here is that the things that we are going to present in the next slides can be tailored to the specificities of each case of the people in the audience.
Thank you. Yes, I also would like to reiterate to not hesitate to post questions in the Q&A through Slido, and we will have time in the end to get to them. And also, please do not worry if there is anything that seems super ambitious or seems super maybe complex, because this is a rather complex topic, as you probably all know, coming from these companies. So we are doing our best to decode this for you. But please also, if anything is unclear, don't hesitate to ask us. And we also will have a very in-depth publication coming up in the next couple of weeks. Keep following Plan A to also learn a bit more, and the slides will also be shared. So please don't worry about that. With that, I would like to go and give word to Carsten, who will walk you through these tangible actions, which we have classified for the purposes of this webinar across two main areas in a software company, so to say, lifetime or life cycle. So first is the development phase. So this considers things like the coding and the design of the software, as well as the infrastructure and architectural elements. And then the usage phase. So this is usually what is understood under GHG protocol as scope 3 category 11, ranging from consumer device use, so also the choice of the device that is being used, or where the software is being streamed on, for example, the network use, but also data centers. However, as Carsten has made me aware, these things are intertwined. A decarbonization action in the development phase may translate into decarbonization in the usage phase, which is something that he'll walk you through. So please, Carsten, join us and tell us a bit more about this.
Yeah, thanks, Claudia. Yeah, exactly. I mean, it's as you mentioned, there's no silver bullet, let's say, to solve all problems. So let's maybe just start with the next slide. When you think about decarbonization of software, you probably think about writing efficient code, writing about software which is just running faster. Maybe let's have a quick look at that. There are a couple of things you could do. And just as a disclaimer, I can only give you today a couple of ideas. I cannot run through everything in detail, unfortunately, but please bear with us. We do have a lot of documentation upcoming, so there it will be described again. So when you are about to set up a new project, let's say, and one thing you can of course do is to choose the programming language based on the use case. So there's not a general recommendation for any programming language. Usually in your company, you have your tech stack anyway, so you can only choose between a couple of them. But if you have the chance to start a new project, you might consider one programming language over another. So for example, interpreted languages like Python or PHP are usually not so efficient like those like Go or C, which get compiled, where you have the code in machine form already. If you can choose, you could choose a more efficient programming language also based on the use case, but I'm not saying that you should now start rewriting all your code bases into other code, because this is really something which requires also a lot of time, a lot of resources. So don't do that. There are other good things which we can do. For example, also again, if you ever have, as a developer, have to implement an algorithm, you can of course choose usually between a couple of them. Also here, typical IT answer is it depends. Depends on the use case. For example, sorting algorithms, you do have algorithms which are very efficient with small sets of data, but they get very inefficient with large sets. Then you have algorithms which are maybe not so efficient with small sets, but quite efficient with large sets. So really, depending on the use case, you can choose your algorithm. This is usually called the big O notation. So it's an expression of how the runtime of an algorithm evolves with the size of data. But this is really usually software developers nowadays, they don't really implement any algorithms anymore because there are libraries for everything. One thing where I think where you could have a much bigger effect would be looking at the database. For example, I am a backend developer, means we are the people who are responsible for sending data from the browser to the database, let's say. And a lot of things which you can do there can really boost the performance. So for example, database schemas, the way how you store data in your databases, if you optimize these, you can get a much better performance. One thing which, if I would get €1 for every time I saw that, I would be a rich man, probably would be add indexes to your database, to your tables. These are the most common things which are somehow always forgotten, but cost a lot of performance. These kind of things. Also, when you have your queries, you can always optimize database queries. So when you query data from your database, start optimizing that. How you get an idea of where to start would be the code profiling. This is the technology. Yeah, basically you run your application and you gather statistics while you do so. So there's a background job which gathers statistics on, for example, how often functions are executed, how long the execution times are, maybe maximum or average. And we have here, for example, this is a piece of code which I found in some code base. This is not to blame anyone. This is just something that can happen. And don't worry, we will not go into coding here in detail. It's just an example of what to look for if you are a developer. So we do have here a loop which is being executed 10,000 times, or actually it's 10,001 times to be precise. So every time the loop gets iterated, there's a lot of data written. There's some text data written into a variable, to an array here. And every time we execute this loop gets iterated, there's a function, a translation function. Here I highlighted it in red. The translation function, it always translates the key row, so the word row, into the current language. And this is done now in every iteration of the loop, this can just happen, can get copied there. But in the end, since the key row never changes in this loop, this is highly inefficient. So in the end, you could just execute this function once, store the result outside of the loop, and then use the result inside the loop. So these are the things which you would get through code profiling. It would just show you basically, okay, suddenly you would see, why is the function trans now executed 10,000 times? And you would start looking into it. One last thing on the programming side. would be to start agreeing on performance budgets, which same as everybody else, like money budgets or whatnot, you should agree on some budgets which you should not exceed. So for example, if you have a website and you agree that the time to first interaction, like the time until people can actually use the website should not be higher than 3 seconds, let's say, just a number. And you can check these values automatically. And at some point, if this number, if it's longer than 3 seconds, you get an alert and you should then start looking into your website. Why is there something going slow? This is a waste of energy, of course, and very bad for conversion rate. So it has actually both good effects, not only that you save energy, but also you have happier customers because nobody likes slow websites. So these are the things which you can implement. Also, you could do this for backend processes, of course, just an idea of how to really not only implement efficient use cases, but also keep them efficient by constantly checking them. Okay, if you can go to the next slide, please. So this was now really in depth on programming. I think for most use cases, it's easier to start probably on the infrastructure side. So you have your existing application already. You don't want to rewrite everything, which makes sense. So you could look into concepts like, for example, auto scaling. This means that you automatically adjust the computation power on the demand. Let's say, typically back in the days, you had one server where let's again say, for example, a web application, where the web application was running on, you had one server, and that one server had to be powerful enough to also serve all the customers in peak hours. So you usually have your peak hours where most users are on your platform. And then you have times when this is not the case and the server is more or less idling around. With cloud technology, for example, you could set up now, you would rather use a couple of smaller virtual servers, and depending on the CPU usage, for example, you would then add more virtual servers if you need them, serving more customers. The customers then go away again and peak hours are over. You would take off these servers again, scale in, and then you are very efficient with the cluster you have.
Quick question, Carsten. You mentioned the shortcut, the CPU. Probably this is something you, as a software developer, come into contact very, very often, but maybe some don't. So could you please tell us a bit more about CPU?
Yeah, I'm sorry. Yeah, true. So the CPU usage basically describes how much actual computational work is done on the server. So the CPU is the central processing unit, and this is the main chip which does all the computation. And at some point, if the usage of that CPU is too high, then people have to wait because it just has to queue all the jobs. It cannot do everything at once. So at that point, the CPU usage is just too high to serve all the needs at once. And if this usage is, if the CPU usage is too high, you should already start not maybe at 100% or at 80, you should already start at 50%, say, okay, looks like we are going out of CPU power soon, so let's add some new resources to the whole stack.
Cool, thank you. Maybe just quick comment on Carsten's expertise. So Carsten has also published two great articles going into depth of all these topics that he's just now discussing. So in case you also want to maybe simultaneously open that in a new tab, my colleague Mina has just linked it in. Yeah, you should see it pop up on your window. So if you want to save that for later and learn a bit more, you have that source available. But back to you, Carsten.
Yeah, thank you. Yeah, I also have to be mindful of time a little bit. So I cannot go through everything here really in detail. Maybe one thing which I would really like to highlight is think about the resource usage. Really try to avoid everything you can, everything unnecessary. Right sizing, for example, is a term for choosing the right size for your server. So this is a typical risk management thing, if you like. If you are not sure how much users you will have, you rather choose a big instance, a big server, which can potentially serve all the clients at once. But at some point, you might find out that, for example, the database server which you have is much too powerful for your needs. So then you could start moving it to a smaller size. And this has to do with and this is really a term which is hard for Germans to pronounce. It's the energy proportionality, means that if a server is utilized on a low, is like not highly utilized, it's not so energy efficient as if it would be highly used. So the more usage you have on a server, the more energy efficient everything gets. So you should really try to utilize your servers as much as possible. There's this one story from a company called VMware, which I'm sure a couple of people know. they did a data center move a couple of years ago. And during that move, they found out that like 2/3 of their servers, which they had in the data center, were either underutilized or not used at all. So they were just idling around, still consuming a lot of energy and producing a lot of emissions. This is a typical example of it can happen. So as you leave the room, you turn the light out. So you should also have a look at your servers, at your services, and shut down everything you don't need. Okay. Yeah, maybe you can just go to the next slide then. These were the simple things you could do, or the easy ones, the quick wins, let's say. A couple of other things which probably take a bit more time, but are still worth exploring. My point of view is the event-driven architecture means that if you have a couple of services which are intertwined, which are interconnected somehow, how do they interact with each other? So for example, you could have one service which is waiting for updates from another service, and it always goes to the other service and asks, are there updates? No. Are there updates? No. And this is very inefficient. You could also switch to a process called, or to a concept called event-driven architecture, where the one service where a change happens, it kind of communicates these changes to the other services, letting them basically know, look, there's a change. Now you can pull the data from where you need it and do your action. This just requires a bit more work. Usually you would use queues for that, or a message bus. So it's not that easy, but it's still quite useful. Other topics, caching is also, every developer probably agrees that caching is not easy, or it's one of the hardest things to do properly. But still, caching means that you you store results of computational efforts somewhere where it can be easily accessed, and then you can save this computation. So for example, I gave you just this example before on the 2 slides before, where we wrote the result of the one function into a variable instead of calling this function every time. This would be in-memory caching. So if the code is done, let's say, if the program is over, it will disappear. Other things would be the response caching. If you provide an API to your customers and you know that certain responses don't change that often, you can get the response you collect the response from the database, which is usually quite slow. Then you store the response in a cache, which is actually also a database, but a very efficient one, which is only meant for this one job. And next time, the same response will be then delivered from cache, other than using the rather slow and expensive database. So these are concepts. Also, of course, browser caching is something which you should really utilize. The more data is stored on the client side, like in your browser here, the better. In general, there are also a couple of other things you always should consider, is like reducing data transfer. For example, on websites, when I see, I don't know, large images, JPEG with 10 megabyte, not lazy loaded, means that it's always loaded, although it's not even visible. So these kind of things you can also implement to reduce data transfer. Also, the API responses should not be super huge, should rather be a bit smaller. Maybe don't just return all the data there is, but rather return just the data the client needs. And if they need more data, they can, Okay, again, being mindful of time, I would like to rather switch now to this carbon-aware computing concept, which I think is highly interesting, because so far we were just looking into how can we do things more efficient. But now we can also think about how can we take information about the current carbon intensity into account. So carbon intensity means, in this case, how much carbon emissions or equivalents or how much carbon is emitted for every kilowatt hour. In this case here, this is a screenshot from the tool Electricity Maps. And it shows here for Germany actually quite good value. This was yesterday during the day, quite a sunny day, 250 grams of carbon equivalent per kilowatt hours. This is not so bad for Germany, but you can see here on the map, and it's quite easy to see, the greener the better, let's say, the lower the carbon intensity. So instead of running your servers in Germany, where the carbon intensity, I think an average is around 400 grams per kilowatt hour or something like that, you can permanently move your server somewhere else. You could operate them in France, for example, or in Sweden, where the carbon intensity is lower during the whole day. So on average, it's quite low there. You could do that. This is what is called regional shifting. You could also do this dynamically even. So you could say, if you have a couple of data centers around the world, you could move your computation to regions which at the moment are quite have a low carbon intensity. And then if over the day, the carbon intensity changes, like with where solar power is available, and then you can move it. But this is a very, let's say, theoretical concept. I'm not sure if this is really done. But the regional shifting, like using data centers where the carbon intensity is lower, this is really an interesting point. Okay. Yeah, again, I listed here just a couple of sources like energy charts, electricity maps, and what time. There are other sources for this. The cool thing about these sources is that you can also get a forecast of the carbon intensity. So maybe at the current point in time, you know that the carbon intensity is still quite high, but you already get the information that this will change over the day. So maybe a computation which you will do now would have a carbon intensity of, I don't know, 300 grams per kilowatt hour, but maybe in 2 hours it will be lower. So if you can, you could defer the computation to a later time. This is a concept which is quite interesting. For example, for big compute, like training large language models, it has to be implemented. It's not something which also every user would be happy to. Let's say if you want to get an export of data and the software says, okay, you will get your export in 4 hours because right now the carbon intensity is too high. This is something I think we have to work on the concept how users would like to use our software. And the very quick last thing here is the demand shaping. This is also very theoretically still. So you could say, if I know that the carbon intensity is high, I could probably reduce the quality of images or the quality of the video stream sent to the users. At times when the sun is shining, you have your full Ultra HD, and at night times you probably don't. I'm not sure if this is a good concept, but just to give you some inspiration of what you could do with all this information that you have nowadays.
Yes, thank you so much, Carsten, for all these great tangible actions. And we would like to now ask our audience, before we go to the next section where César speaks a bit more about cloud services and energy considerations, if your company has already implemented some of the actions we have mentioned. We know it was quite a lot of them. And if you've implemented some other actions, please don't hesitate to also type it in the chat and let us know. Let's inspire each other, so to say, if there's anything else you have implemented. And even if you implemented some of the ones we mentioned, let us know if you had any issues in the Q&A. I already see some interesting questions coming in, so thanks for that. Let us know also in the chat or in the Q&A if you've implemented some other actions or even the ones we mentioned. Great to see that the majority of you have implemented some of the actions. Super happy to see that. And even though 20% hasn't implemented any of them yet, I hope that this webinar can be a good source for your or source of inspiration. We will send the slides, so you will have the actions, so to say, by hand. You can either implement them yourself or work with your colleagues in the company to start maybe thinking about them. I think the first good step is already always to start a conversation, right? César was also mentioning education as a key pillar. Even for those who haven't implemented any actions, I think this is a good place to start. And with that, being mindful of time and that we also want to have time for your questions, I'd like to move on to the topic of data centers and cloud services, which actually some of your questions are related to. I'll just quickly introduce this graph and then hand over to César to give a bit more detail. But essentially, this graph just shows, and you probably are all very well aware of it, the impact of cloud computing and data centers in, so to say, proportionally to other industries, and it's a share of global CO2 emissions generated. So you see that it's between 2.5 to 3 to 7% of global CO2 emissions, which is bigger than aviation or shipping. So this just illustrates the high impact this has. And with that, I hand over to César to tell us a bit more about these and how you can essentially think about them as a software company.
Yeah, thank you again. So in spite of you being the actual user, let's say, of a server provider by a third party, or if you manage your own data centers, it is important that you can either measure or ask to provide some energy efficiency key metrics, right? Probably a lot of you have been already aware of this very known metric that is the power usage effectiveness, the PUE, because this is the mainstream metric to measure energy efficiency, right? And it is basically a ratio between the overall energy consumption of the data center over the energy consumption of the specific IT equipment, right? So the idea here is to provide, as I said, a metric of the energy efficiency. But this metric is or should be complemented with others because it's not perfect. That it doesn't tell a whole story about the actual energy efficiency and other practices that we can implement in order to reduce the energy consumption and therefore the emissions. So we suggest some of them, like for example, it is also important that we can understand what is the total energy consumption. Yeah, pretty obvious. I say what is the overall electricity consumption of the whole data center, including the IT equipment, but also the complementary services. Or another one that is very important is the carbon usage effectiveness, that it is very similar, or in concept is similar to the PUE, that is basically what are the emissions related to the total overall energy consumption in relation to the emissions of the energy consumption of the IT. So this again provides a measure of the efficiency on what are the actual emissions associated with the IT hardware that we have in the servers. Another important metric and also very interesting is the renewable energy factor and on-site energy fraction. And this relates, as you all know, data centers are big infrastructures that can allow for the implementation of renewable energy, especially solar photovoltaic panels, right? So it is important that we can recognize if the data centers that we are using are actually consuming some electricity, renewable electricity that is generated on site, or in any case, if the electricity is coming from the grid, what is the fraction of electricity that is coming from other sources versus specifically renewable energy? Then we have the IT usage effectiveness. Again, this is for understanding how efficient is the actual computing work of our data center versus the total infrastructure and therefore the consumption. So we can also plan for improving the efficiency of the computation power of the data center, or to look a provider that can offer up a solution for this. And then we have the energy reuse efficiency. This is related, as you all can imagine or know, that data centers and the IT hardware produces a lot of heat, right? And that's exactly why we need these cooling systems to remove this heat that normally it is released to the atmosphere. But given that we have this energy that is lost as heat, we can reuse it to, for example, produce heat that it is usable, for example, for district heating or for boiling water or for other energy efficiency purposes, like even creating or producing some energy. So we are placing here not the long list of energy efficiency metrics that are available, but some of them that we think are critical and very important. Additionally, I would like to mention that these are also part of directive initiative that is coming at the European level. And this initiative is placing all these metrics. So now the server providers that will be located here at the European level will have to report on this. So we expect that in the coming months, this will be public information that the data centers will have to provide. Then the next point is that it would be useful if we can find data center providers that can at least show commitment and to show that they are improving, making progress, right, to align with the climate change global goals. Like, for example, again, European initiative that we have is the Climate Neutral Data Center Pact. So at least we have a better indication of if the data center it is complying with these initiatives that are placed on a voluntary basis. And if we have server providers that not fulfill any of these requirements, of course, the suggestion is please change the server provider accordingly. And yeah, Carsten, I think that probably you can tell us a little bit how difficult or of actionable is to change the data center providers. If you go next, Claudia, thank you. We don't want to deviate from the topic of this webinar, but we thought that it is very relevant information for you. Here at the right side in this graphic that it is taken from this very interesting study that you have the side there, it is making an analysis of the 5 top tech companies in the world, but additionally some other companies, the relevant ones in the fashion industry. And what it shows is how we can make a quality assessment of the energy procurement. And as you can see, there are some companies like, for example, Apple or Google, that it is very, very credible, their energy procurement and reduction claims, while other companies are not that credible, right? In a nutshell, what is the point with this? That in the generally publicly available information about energy procurement, like for example, the sustainability reports of the big companies or the big data services providers, a lot of them make these big claims that almost 90%, 95, 100% of the energy procurement is already coming from renewable energy. And this can be a little bit misleading or hide something that in fact, if especially these claims are backed with the usage of renewable energy certificates, or here in Europe, the warranties of origin that are unbundled from a specific hourly match renewable energy procurement, probably they do not match the electricity consumption with the electricity production. And therefore, the meaning of that is that potentially the electricity consumption that these companies are claiming is not actually there. It's not backed by actual renewable energy production, and therefore the emissions can be still high. For the sake of time, I don't want to go that deep into the details, but I want to tell with all of you that we are in the coming days launching also a publication in which we will discuss this topic with detail. But here the main message is that please take and handle this information that we can find in the public reports also with care, because these claims can be a little bit misleading in some cases. So, but I think that we are fine. And because of the time, I think that it's fine to proceed.
Yes, thank you very much, César, for this. A lot of information we covered. With that, we would like to jump to conclusions before the Q&A. So we're coming now to the sections that everyone is looking forward to. Quickly, just to summarize what we discussed today before we answer your questions. So first, we reflected, so to say, on the status quo, where the emission hotspots in a software company come from, and outlined the, so to say, journey and ambition setting. Then Carsten presented decarbonization options or opportunities in the development and usage phase of the software, after which we zoomed in a bit on cloud providers and their energy considerations, which is what just concluded with César. And one last time I would like to highlight, we will provide a lot of more information in our additional publication, which you can keep track by either following us on LinkedIn, either one of us or Plan A in general. We also have a dedicated website where you can keep track of all things software and IT. So please don't hesitate to also check that out. Mina just posted it as a pop-up window. And with that, thank you everyone for the questions. Just quickly highlighting the page that I just mentioned. And now we would like to move on to the Q&A. So first question we have, how can we reduce emissions from our software when we only use cloud-based services and we have no servers? I think César just outlined a couple of strategies pretty well. So there is all these metrics that you can check. Carsten also highlighted some strategies on how to maybe change the provider, but I don't know, Carsten or César, if you want to add anything else to this point.
Yeah, I can give it a try first, if I may. I would say that I hope that with those suggestions that we have presented so far, it is a little bit more clear on how a company that is producing a software that is based on a cloud can decarbonize. So these several examples that Carsten has presented, all of them go into the direction of making the software more efficient, requiring less data transfer and calculation power from the servers. And the effect of that will be that the data server, will consume less energy, and less energy is equals to less emissions, right? So this is the main point. And additionally, as I was mentioning just before, it is also very important that we are aware of what is the energy efficiency metrics and the overall energy consumption of the data center providers, and therefore we can select a data center that is located in a less intensive energy grid, or that is making in general a better usage of the energy, a more conscious usage of the energy, right? So these are the, I would say, more actionable actions that a software company based on cloud can take. And so that I don't know, Carsten, probably you want to add something here.
Thank you very much. There is a question about if we can share the presentation, please. Yes, of course. As mentioned, this will be shared after, and you should get an email. And there's also all these links that we shared overall where you can find more information. I also saw a question about, are there any calculation estimations on how successful these strategies would be in software decarbonization? So I assume this question is directed at what's the, so to say, emission reduction potential of each of these. Again, I will refer because we could speak another hour about all these estimations. So I would just maybe refer you to the upcoming publication, which is a really long and in-depth report, which we have been writing and working on for a long time. So please don't hesitate to follow us, and this will be something that will be published, and you will find these estimations there. Yeah, stay tuned. Sorry, I can't give you a better answer at the moment, but yeah, as I said, this topic is quite complex, and I think Carsten also said once that we could speak about this the whole day. So that's the answer to this question. Maybe we have time for 2 more questions. Maybe this one to César first. The really actionable insights to decarbonize software. Thank you. Would you explain to us how to get to a baseline of emissions our software is responsible for? So baseline emissions is something that César has a lot of experience with. Maybe I hand over to you.
So here, of course, for example, we at Plan A have developed an emission calculation for the software industry specifically, so taking into consideration specific elements like, for example, the PUE, but also business activity data like the data transfer between the software company and, for example, the data center. And we are also considering other elements like, for example, the energy grid where the data center is provided, also the devices in which the software is running. So I would also recommend, if you can, to take a look at the previous webinar for a clarification of how the emissions are calculated. But yes, there are these methodologies, and we are following the GG protocol recommendations, but also dedicated protocols and standards for calculating emissions for the software. So it is possible to calculate the baseline for emissions, right? So that is of course, the first glimpse that we can have, and therefore after that to identify the carbonization levels. I would say that if you would like to go deep into the details of this, we are here open. We can do some demos and some specific and detailed explanations for your specific cases. So we are happy to do so as a demo presentation of our products and services.
Yes, and also we are open. I think this is valid for Carsten, César, and myself equally, that we are also open to get any questions either via LinkedIn or write us on our. I think you should have maybe even our email addresses in a follow-up email. So please, we are also open to answer any questions afterward. Maybe just to follow up on what you said, César, in terms of the previous session. So maybe not everyone is aware that we also hosted a webinar on decoding carbon accounting. Maybe I would ask my colleague Mina if she can share a link to this from the Plan A Events Hub, so that the people who haven't attended that can also watch that retrospectively. Thank you very much in advance, Mina. Being aware of time, maybe we have time for one more question, which is this one. If I go hierarchically, are companies responsible for emissions associated with employees' home office? If yes, what are the best practices to address that? This question can be interpreted in several ways, right? Because if you mean software usage associated with companies' home office work, or if you mean in general home office emissions, which is something, yes, that is considered when calculating a corporate carbon footprint. But maybe I hand back to César as I see you.
Yeah. Very interesting question. In fact, this question applies not only to the software industry, applies to every company that have or that work with home office setup. And yes, the companies are responsible also for the emissions associated with the employees' home office. This is part of the employee commuting. Is an, let's say, expanded scope of this category that is also in the scope 3. And there are ways to calculate this. It is a little bit tricky because it is not implementable, not practical, that we can start demanding information from employees like how many devices you have, how many hours you are actually working with your computer, do you turn off your device at the end of the day. So it is too much information, but we can rely on some credible national averages, so we can calculate on this. And therefore, for decarbonization, I would say that the best practices is to engage with the employees and to make them aware and to educate them on general energy efficiency practices, that there is a lot. We have also written material in our Academy article for exactly this topic, so I recommend that you can take a look there. But for example, things are like we need to turn off and disconnect our devices, for example, if preferable on a daily basis, or we can have this, what is the word for that in English? The connections in which everything is plugged there. So for example, with the one turn off, you can disconnect all the devices. So that is pretty practical. You can also, for example, implement a Class A efficiency equipment and to provide this to your employees so that they are aware, or for example, even encourage them to use a natural light instead of turning on the lights. So in general, I would say that energy efficiency practice is the most actionable and credible recommendation for reducing emissions there.
Given the time, maybe I close off with one last question, which is there was a question about a checklist. Is there a checklist of measures we can take to make it easier to scan our options? So I would like to close with, again, giving a little teaser for the upcoming publication, which actually does include many, many measures, which you can which you can create checklists of, sort of. And we also hope that this presentation has given a first glance at the checklist of sorts. This is a nice inspiration. We can also maybe create a very easy to use one, but we also encourage you to, get in touch with us with Plan A. We can also offer a sort of checklist in the first demo call with you. We can show you what our software company or software product can do for you to scan your options and, so to say, identify emissions hotspots and emission reduction opportunities. And with that, I'm sorry for everyone whose question we couldn't answer, but please don't hesitate to get back to us either via LinkedIn or email or any contact that, the email that you're gonna. And with that, we would like to close this webinar. Thank you everyone for participating. We really enjoyed your questions and hope to see you at the next Plan A webinar in the future. Have a good day, everyone.
Thank you so much for your time.
Bye bye.
See you. Bye.